Okay, so we're going to start our surface area and volume review. 8.7b, I can use surface area formulas for lateral and total surface area of rectangular prisms, triangular prisms, and cylinders. Number 1. A cylinder and its dimensions are shown in the diagram below. What is the lateral surface area of the cylinder in square centimeters? So we're going to go ahead and look at our formula chart. It's asking us for lateral surface area. Let's go ahead and highlight that, lateral surface area of a cylinder. So we're going to look at our formula chart under surface area. We're going to look under cylinder and lateral, and we see that our formula is 2 pi r h. We're going to set up our little table. And then we're going to go ahead and look at our cylinder. So for our cylinder, we're going to identify our bases. The bases for any cylinder or prism that we've been looking at are the two lateral parallel faces. So this circle right here is parallel to this circle down here, so these two are my bases. We remember that height is the distance between those bases. So here's one base, here's the other. This distance right here is h, so we're going to label that h. And then we can look at our information of the circle. So 8.5 is the diameter because it goes all the way across, but that's not necessarily what we want. When we look at our formula, we don't have d, the diameter, here in our formula. Instead, we have r, the radius. So we're going to look at our diameter. Well, our diameter is twice our radius, right? It's 2 halves, so we just want half of it. So we're going to get 8.5 and divide it by 2. So we're going to type that into our calculator. 8.5 divided by 2 is 4.25. It's going to be r, the radius. So now that we have that information down, we can go ahead and plug in. 2 is just 2. Pi is just pi. R is 4.25. And h is 10.5. We're going to go ahead and multiply the numbers that are not pi, so 2, 4.25, and 10.5. So we're going to type that into our calculator. 2 times 4.25 times 10.5, and we get 89.25. So I get 89.25. I didn't multiply pi, so it's 89.25 pi, which is approximately, so we're going to use our pi button, which is next to the h on the bottom left-hand corner, 280, and then I'm going to round, so it's going to be 0.39 centimeters squared, because we're talking about surface area. So here's my answer in terms of pi, and then my approximate answer. Number 2, a rectangular prism and its dimensions are shown in the diagram below. What is the total surface area of this prism in square inches? So we are going to highlight what it's asking for, total surface area of this rectangular prism. So I'm going to go ahead and look at my formula chart. Under surface area, we're going to look for total of a prism. So it's PH plus 2B. We're going to go ahead and identify our bases. Whenever we have a rectangular prism, we're going to say that my base is the top and the bottom unless it specifies otherwise. So this is my base down here, and up here is my other base. And then h, of course, is the distance between it. So here's one base, here's the other. This distance between it is going to be h. So now I'm going to go back to my formula, and it says P, where P means perimeter of the base, the capital P. So I'm actually going to draw my base here on the side, and I'm going to write the dimensions that correlate with it. So this is my base. My dimension is 7.25 by 5 inches. So 7.2 by 5. When it asks me for perimeter, that means that I want just the outside, so I'm going to label these other sides, 7.2 and 5, and I'm going to go ahead and add up those 4 numbers. There's 4 sides to my base, so I'm going to be adding up those 4 numbers. 7.2 plus 7.2 plus 5, I get 24.4. So 7.2 plus 7.2 plus 5 and we get 24.4. H, my height, I have that labeled. Right here, we labeled it as 6.2, so we're just going to write 6.2. The plus is just a plus, the 2 is just a 2. Now capital B, we've been seeing capital B a lot of these last couple weeks, and we remember capital B doesn't just mean the base, it means the area of the base. So what shape was my base? Well, my base was a rectangle. So the area of a rectangle is going to be little base times height. My base was 7.2, my height was 5, so we're going to go ahead and multiply those. 7.2 times 5 in my calculator. And we end up with 36. So capital B is equal to 36. And now we're going to multiply. P and H are next to each other, so that means we're just going to multiply these two. 24.4 times 6.2 is 151.28 plus, now we're going to multiply 2 times B because we had two bases, not just one, so we need both of them. 2 times 36, 72. Now I'm just going to add 151.28 plus 72 is 223.28. My unit was inches, and we're talking about surface area, so that's area that's squared. Number 3, a triangular prism and its dimensions are shown in the diagram. What is the lateral surface area? So we're going to go ahead and highlight this. Lateral surface area of the triangular prism in square feet. So in my name, triangular prism, this helps to remind me what shape my base is. Remember, our bases are the two parallel sides. Well, these rectangles that are shown in the figure are not parallel, they're touching each other. But if I look at my triangle, these two triangles are directly across from each other, they are parallel. So these are my bases, but also my name, triangular prism, that means my bases are triangles. So we're going to go ahead and label this base. My H is not just how tall it is, it's the distance between bases. So here's one base, here's the other. This distance between them is H. And then I'm going to go ahead and draw my base, just like we did earlier when we had our rectangular prism. I drew the base up here. We're going to draw our base, and we're going to write down that relevant information. So I see it's a right triangle right here, so I'm going to put that right angle. It's 4 by 3 by this side right here is 5. A 4 by 3 by 5 triangle. So now that I have my base drawn, I'm going to go ahead and write down my formula. It asks for lateral surface area, right? Lateral. So we're going to look on our formula chart under surface area for prisms lateral, and we see it is PH, where P is the perimeter of my base and H is the height. Well, I already have my H labeled, right? The distance between bases. That's 7. We can go ahead and plug that in. So now all I need is capital P. Well, capital P means perimeter of not the entire figure, of just the base. So that's why I'm going to focus on what the base that I drew. Remember, this is B, our base. And perimeter is just this outside, so I'm just going to add them up. 3 plus 4 plus 5, that's 7, plus 5, I get 12. So let's go ahead and write that there. So I did 3 plus 4 plus 5, and I end up with 12. And P and H are next to each other, so we're going to go ahead and multiply these two. 12 times 7. Let me see. 12 times 7 is 84. And then our unit is going to be feet. We're talking about surface area, so feet squared. And let's go ahead and go on to the next page, my previous page. Capital B. Over here, it was the area of the base. Number 4. A can in the shape of a cylinder has a diameter of 7 inches and a height of 8 inches. What is the total surface area of the can? This time we don't have a picture, but it tells us the information in our word problem. So the diameter of 7 inches is going to be D equals 7, and the height of 8 inches, so that's h equals 8. Let's go ahead and write down our formula and see if we have all the information we need or if we're going to need to convert the diameter. So I'm going to look on my formula chart under total surface area of a cylinder. I see that it's 2 pi r h plus 2 pi r squared. And we're going to go ahead and divide it up. Okay. So 2 is just 2, pi is just pi, but I need r and I don't have that yet. All I have right now is d and h. So I'm going to go ahead and plug in h. H is 8, so I'm going to skip r for now. The plus is just a plus, the 2 is just a 2, the pi is just a pi, and I'm missing that r again, so I can't fill in r squared yet. But it did give me my diameter, and if I remember a circle, a diameter is all the way across 7, and my radius is just half of that. So I'm going to go ahead and get 7 divided by 2, and I end up with a radius of 3.5. So r equals 3.5. So now I'm going to go ahead and plug it in. 3.5. And then here it's not just r, it's r squared, so it's going to be 3.5 squared. And then we're going to go ahead and multiply. So I'm going to start by multiplying the numbers that are not pi. So 2 times 3.5 times 8. 2 times 3.5 times 8, and my calculator ends up being 56. I still have the pi, so 56 pi, plus, now let's do this side, 2 times 3.5 squared, 3.5 squared, and I end up with 24.5. I still have the pi, so 24.5 pi. 56 pi plus 24.5 pi, so I'm just going to be adding these two coefficients, 56 plus 24.5, and I end up with 80.5 pi, because I still haven't done anything with the pi. So I'm going to go ahead and write it here for my answer, 80.5 pi, which is approximately 80.5 times pi. My calculator, 252.90. My units were inches, and we're talking about surface area, so inches squared. Number 5, Coach Dawson wants to paint his storage shed. He needs to calculate the lateral surface area of the shed so that he will know how much paint to buy. The shed is in the shape of a rectangular prism with the dimensions shown below. Including the doors, what is the lateral surface area of the storage shed in square feet? So this time it just wants the lateral because he's going to be painting just these walls, including the doors, and then the other two that we cannot see on the other two sides. But he's not going to be painting the floor, and he's not going to be painting the ceiling. So it's just going to be the walls, that's lateral. And it even specifies for us lateral surface area. So it was a rectangular prism. So my formula is just PH, where P is the perimeter of the base and H is the height. So because I am not painting the ceiling and the floor, that is automatically my base. I know we can't see the floor, but it goes like this. So it's a rectangle. These are my bases. My height is the distance between bases. So between the two bases is 7 feet. That's H. So I can go ahead and plug that in already. 7. I'm going to go ahead and draw my base separately. It is a 15 by 10 base, because that's what I label as capital B, a 15 by 10 rectangle. So if it's my perimeter, I'm going to add up the sides. Now I don't have just these two sides where I have numbers. I also have these two sides as well that I need to add. So this side is 15 also, and this side is 10 also. So 10 plus 10 plus 15 plus 15. 10 plus 10 plus 15 plus 15. I end up, that's 30, 40, 50. So we're going to go ahead and multiply these two because P and H are next to each other. So 50 times 7, 350. And my units were feet squared. Now let's move on to volume. So 8.6a, I can describe the volume formula V equals BH of a cylinder in terms of its base area and its height. So this time we're not even going to need to solve anything. We're just trying to pick the one that is correctly set up. So a cylinder and its dimensions are shown in the diagram. Which equation can be used to find V, the volume of a cylinder? Again, it's just asking me which equation is correct. So this is a cylinder. We're going to look on our formula charts, and this time we're finding volume. So we're going to look under the volume section now. We're not looking under surface area anymore. It's volume. So for a cylinder, it's V equals BH. So we're going to set it up in our little table. And just like before, when I had capital B, so capital B means area of the base. So I need to identify my bases. Well, for a cylinder, my bases are the circles down here. I don't have a number for h, the height. It just tells me that it's h. So I'm going to literally use h. Whatever information it gives you, that's what you're going to use. If it gives you a number, you're going to use that number. If it gives you a letter, you're going to use that letter. So here it just tells me h. So I'm going to use h. But capital B means area of the base. Well, I know that my base is a circle, so we're going to use pi r squared. It tells me what my radius is. It's 3, so we're going to do pi times 3 squared. So this is what I'm going to be multiplying. Pi times 3 squared times h. So capital B times h. So I'm going to see which formula shows that. So they all have pi, 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 pi. So that part's good. And then we have 3 squared. This one has 3h squared. That doesn't match what I wrote because h doesn't have anything up here. It's not squared. It's just h by itself. So this one's no good. 1.5, well, I'm supposed to use r my radius. I did use r my radius. It says r was 3. It was just from the center to the edge, not all the way across. So I'm supposed to use 3, not 1.5. So this one's not good. Here's 3 squared. Okay, so this one's okay. 1.5 squared, again, not what I'm using. So right now, it looks like C's my answer, but let's finish checking it. Times h with nothing attached to it, times h with nothing attached to it. So this one's good on that end too. So my answer is C. Let's go ahead and look at the next one. Here's another one where we're just going to find the equation. A hat box in the shape of a cylinder is modeled below. The diameter of the cylinder is 20 inches. The height of the cylinder is 5. The volume of a cylinder can be found by using the formula V equals BH. Which expression can be used to determine B, the area of the base of this hat box in square inches? So we're going to look at our information and what it's asking us. It's not asking us to solve for the volume. It's asking which expression can be used to determine capital B. Well, capital B is not just my base. It's the area of a base. And if it's a cylinder, then that means my base is a circle. So the area of a circle, capital B, is going to be pi r squared. That's my formula for area of a circle. We can see that under the area section of our formula chart. So in order to use this formula, pi is just pi, but I need r, the radius. This 20 that goes all the way across is going to end up being my diameter. Diameter goes all the way across. But I can use that to find my radius by dividing it by 2. So radius is 10. I also have a height of 5 inches that it tells me. But if I look at my formula, do I have h anywhere here? No, I don't. So I don't need that number for this problem. So pi is just pi. Let's make our little table, actually. Pi is just pi. My r is 10, so it's going to be 10 squared. So I'm going to look for the one that matches 10 squared times pi. Whether you multiply pi times 10 squared or 10 squared times pi, it's the same thing. 3 times 5 is 15. 5 times 3 is still 15, whether you multiply one first or second. So just keep that in mind. So I'm looking for pi times 10 squared. So this one doesn't even have pi in it. C doesn't even have pi in it. D doesn't even have pi in it. So I'm down to A and B. Well, it said to use r my radius, so I chose to use 10 squared instead of 20 squared. So A is the one that shows 10 squared. 8.6b. I can model the relationship between the volume of a cylinder and the cone with congruent bases and heights. Number 8. Look at the figures below. Which statement correctly describes the volume of the two figures? The volumes are the same because the base areas are the same. So before we finish reading the rest, let's go ahead and look at the information. So the height is 7 on both of them, so that matches up. The radius is 3 on both of them, so that matches up. So that means that this circle, the base, are exactly the same. And that means that the height is exactly the same. So if we remember that video that we had watched with the popcorn, I know that 3 cones equal 1 cylinder, which means that 1 cone is 1/3 of a cylinder. 1 cone is just one portion of it, right? So I'm going to look for the answer choice that shows that relationship. So the volumes are not going to be the same. The cone is going to be smaller. 3 cones can fit in 1 cylinder. The volumes are the same because the dimensions are the same. Again, they're not going to be the same. The volume of the cone is 1/3 greater than the volume of a cylinder. So this is saying the cone is not only the same size, but it's actually saying that it's greater than. And we know it's not greater. Actually, these should be x's. And we know it's not greater. Let me erase these. These should be x's. Sorry about that. So it's not greater than. The cone is actually just a portion 1/3 the volume of the cylinder, D. Number 9, a ball shaped like a sphere has a diameter of 11 centimeters. What is the volume of the ball in cubic centimeters? So we're going to go ahead and look at our formula chart. Again, we're looking for volume. So 8.7a, I can solve problems involving volume of cylinders, cones, and spheres. And then this is a sphere. So I'm going to go ahead and look at my formula chart. Under the volume section, I have one for spheres. And this is probably one of our easiest formulas, 4/3 pi r cubed. And then I'm just going to plug it into the chart. 4/3 is just 4/3, pi is just pi, and then we have r cubed, r to the 3rd power. So I'm going to look at my word problem. It says the diameter is 11 inches, so that's telling me d is equal to 11. This is not a d, this is r. We're looking for the radius, so I'm going to get the 11 divided by 2. 11 divided by 2, so r is 5.5. So we're going to go ahead and do 5.5 cubed. And so I'm going to multiply the numbers that are not pi, 4/3 and 5.5 cubed. Remember, in order to get the cubed, we're going to use our caret button, our caret key. It's right next to the x squared button. So it's on the left of the 4. It looks like this. And once you type 5.5 and then you press this button right here, it's going to go ahead and give you an exponent, and you're able to type in the 3. So control divide, and I can type in 4/3 times 5.5 cubed. And I end up with 221.83. Still have the pi, so pi. Can write that for my answer. 221.83 pi, which is approximately, so now I'm actually going to multiply that times pi using my pi button, 696.91. That's my approximate answer. For questions 10 through 12, use the image below. What is the volume of the, so question number 10, what is the volume for the container shaped like a cone? So here's my cone. And actually I'm missing the inches, the units, but this is going to be inches. So I'm going to go ahead and write down my formula for a cone. So looking on my formula chart, it's 1/3 base times height. So I need to identify my base for a cone. My base right here is the only flat surface, the circle. So because my base is a circle, we're going to replace that with area of a circle, pi r squared. Remember, capital B means area of the base, in this case, area of a circle. So since that's what shape my base is. H is going to be from this base up to that vertex. That's going to be h, so this is going to be 18. And 1/3 is just 1/3. So I'm going to go ahead and plug in pi times r squared. R is from the center to the edge. That's 7. R equals 7 from the picture. So it's going to be 7 squared. So I'm going to go ahead and multiply my numbers that are not pi. So 1/3, 7 squared, and 18. So control divide brings up a blank fraction on my calculator. So 1/3, go to the right, 7 squared times 18. So we're multiplying these 3. And I end up with 294. So my answer is 294 pi, which is approximately 294 times pi, 923.63. And then inches cubed, because we're talking about volume. What is the volume for the container shaped like a cylinder? So now we're going to use our cylinder formula. If I look at the cylinder of my formula, on my formula chart, it's just BH. So I need to identify my base. My base right here are the 2 circles. The distance between my 2 bases is h, the height. So I automatically have the height. I can go ahead and write that, 40. Since my base is a circle, just like before, we're going to replace that with pi r squared. Pi is just pi, but r, my radius, looking at my circle, it's just halfway, so that's r, my radius, is 25. So it's going to be 25 squared. I'm going to multiply my numbers that are not pi, which is 25 squared and 40. Make sure you square that 25. 25 squared times 40 is 2,500 times pi. And I get, I'm sorry, it's supposed to be 25,000. Forgot a 0, so let me fix that. $25,000. So 3 zeros times pi. So my answer is 25,000 pi, which is approximately 78,539.8. And then inches cubed. So the volume of the cylinder is about blank cubic inches, greater or less than the volume of the cone. So I'm going to look at my volume of the cone, 923.63, the volume of the cylinder, 78,539.8. So the cylinder is definitely greater. And in order for me to figure out how much greater, we're going to go ahead and subtract them. 78,539.8 minus the smaller one, the cone, 900. Oops, I forgot a number here. 39.8. Okay, so minus 923.63. So we're just going to type those into our calculator. We're not even going to worry about subtracting those by hand. And I end up with 77,616.2. 77,616.2 cubic inches greater. So the cylinder is greater by 77,616.2 cubic inches. So make sure you take home your review, you study it, and you bring it tomorrow for your test.